Today we've got a Rotel 240 for a service. You may remember some months ago I did a end user. We don't, as you know, we normally only deal with the trade, but during the lockdown period we have helped some end users. And he sent in a Uniden 300 base station, and we did all the things to that, and it works great. Well, the Uniden sets tend to be slightly deafer than the Cybernet sets. So to his amazement, the Uniden 300 came back with better sensitivity than his Rotel 240, which he thought was working fantastic. So now he's sent in his Rotel 240 in the hope that this can now be better than his Uniden. So I've got a right angle plug which goes a very funny way. Right, well there you go. And I haven't got a power lead, so what we're going to do, we'll have to shove the crocodile clip leads in. So if we put the positive one there, the negative one there, hopefully never the twain shall meet. Right, here we go. So we want squelch, that to fall, that centre, CB, normal, normal, centre. That doesn't work, does it? Oh, it does. Take my words back. So, what we will do is we'll write the current situation down, so then we'll know whether we've made an improvement or whether we've fixed it worse. Which would be fun. I've probably told you that story before. I took a starter motor from a Datsun pickup truck I had in the very early 80s, and the starter motor was playing up. So I took it into an alternator and starter motor repair shop, and a bloke was in there complaining about his alternator, his starter motor. "You fixed it worse," he said, and that's a phrase I've taken on board. You fixed it worse. It's a fantastic phrase. Right, so we'll put picture in picture on. It is on. And it's in the wrong position. I knew there was something not right. Let's see what the transmit power is. So I'm going to start with the 3 watt range, so we should get beyond full scale deflection. We do. He's actually doing 4.6 watts. So I wonder what it's doing on other channels. So on channel 1 it's doing 4.6 watts. On channel 40 it's doing 4.5 watts, so it's well balanced. Now for some reason the digital display isn't on my power supply, so we'll just see where we are with the power supply in case it's at some ridiculous voltage, and that's why we're getting that reading. So 13.5 volts, so we are where we should be, 13.6. So that's going to have to come down. Right, deviation 1, 2. Where are we with that? 1, 2, wallow. 1, 2. That's a bit quiet. Wallow. 1.8 kilohertz. So that's wrong and that's wrong. Frequency. Switch over to the other camera. 27. Oh, still on channel 40. 2779067 is way off. Well, we'll do that immediately, because that's the easiest thing to fix if we can just find the trimmer capacitor and change glasses in doing so. Which is there. Oh, look at that. Now, it wasn't out of spec, but it was edging towards that way. So that's that done. We'll be setting the VCO up as well. As ever, I've got my eye on the time. I've got a shopping job to do for one of the elderly parishioners again. Okay. So we'll better switch on the SINAD meter. Let's see where we are. So for 12 dB SINAD, it's very good. There you go. 0.52 microvolts. So I'll show you that. So we're in the 1 and we're on the upper scale. There's the 5. So we're 5.2, just over the 5.2. So that's where we are, and it'll hear down to 0.2. So I'm going to look, visual look, do all the capacitors look okay? These radios don't suffer from that, but occasionally you can have a radio that's been overvolted, and so it just needs looking at, or something like that, sorting. But no, it looks fine. So, without further ado, we'll dive straight in to doing the VCO. Let's put that back to there. So I always have to get the service manual out for these because I cannot remember the procedure. We have a nice copy of this which was sent to us by a viewer, but I'm using the dodgy copy because that's what happens here. So we select channel 40. That's channel 40. We need negative, not to chassis but to real negative. So we'll use one of those cans for real negative, and we want the far side of resistor 4, and we've got 3.77 volts. Well, we had it while I got the prod on it. So what should we have? Well, we should have 4. It's neither here nor there, so we'll just turn that coil so we've got 4. This is so it doesn't end up with channels dropping out in temperature extremes. So we're going to transmit. It's got 3.3, so we'll just pop that up. With the trimmer capacitor CT1. I'm just going to turn that round a bit. I think it's got some dirt in it. I think 3.84 will do me. Let's check where we are on receive. 4. Transmit 3.86. So now we go to channel 1, and they want you to prove that it's between 1.8 and 2.5 volts on transmit. And we are at 2.13, so that's well within the 1.8 to 2.5. And on receive, it needs to be between 1.9 and 2.5, and of course it is. So that's that done. That's the adjustment that eludes a lot of people. They miss it out and then channels go AWOL. So we'll go back to channel 20, so we're in the centre of the band. Now we'll tune the radio up. Well, we know it's doing decent power, so we just need to go through the transmitter, maximum, maximum, maximum. And then with a green trimming tool that isn't worn out, that's worn out. Better go looking for one. Okay, so it's normally a green tool, but it's a different make of blue one. So we need to do these for maximum, which they probably are. Maximum, maximum, maximum. So that's unfortunately how it's been left, which is poor because it puts the thing under a strain. Other glasses. So L4, L8, L9. So we need to rotate L4 clockwise until we get 4.4 watts. So we're at 5.5. No, we're not. We're at 4.6. Can't even read my own display. So that's about 4.4. And then they want you to drop it. Let me get you to the right bit. And L9 counterclockwise till they say 3.8. Well, we're not going to do that. We're going to do it to 4. That's a generous 4.05. So now we need to check it somewhere near on 40 and 1. And as it came, it was pretty close. But that isn't how it's done. 4.1 on channel 40, 4 dead on channel 1, so that's fine. And now it's not under strain, so there we go. So we want the meter, the TX meter, to read something near. So let's see what it does. Bangs across to 5, so we need to adjust that so that it's 4. I'm struggling with this mic being this kind of plug, to be honest. So there we go, we're on the 4. We need to check that low power is 400 milliwatts. So we'll go to the low range. So I'm looking for 400 milliwatts. Well, it's actually 2.2 watts, which is useless. So that's 400 milliwatts. Back to normal power. And there we've got 4 watts. That's great. Deviation, that needed to come up a bit. So I want that mic gain 1 to centre. And then we'll bring it up there. Helps if we're on the right reading. 1, 2, that's the one. Bring that up to 2. Then we'll see where we are with the voice. 1, 2, wallow. Testing 1, 2, wallow. It needs to come up a bit further. Testing 1, 2, wallow. That's better. So we're absolutely peaking at 2.5. The original Rotel mic. So that's that. Well, I think that covers all the transmit. So we'll move on to receive. Got my on time. I've got 5 minutes. So, let's go over to the oscilloscope. I'm going to put an S9 equivalent signal, which is 100 microvolts for a CB radio in the UK. I'll turn the bench light off so we can actually see the trace better, and set the volume so we've got a meaningful display. So that's the detector coil or the demodulator. We want absolute maximum recovered audio. And that was already spot on. So now we'll move over to the SINAD meter. And now we're looking to put about 4 dB by turning the attenuator on the signal generator till we get that, and then we'll go to the front end. Wow, what an improvement! Put a bigger signal on for that one. Change tools for that one. You only need one to be out. And everything else so far, there is one hiding under the wiring harness there. They don't tend to get fiddled with because they don't get noticed by Mr. Screwdriver. So go back to the around 4 dB and we'll just do this one again. There we go, we're set. So now let's see what we've got. So we had a very reasonable 0.52 of a microvolt. So I think that's about 12 dB. And now we've got 0.24 of a microvolt. Which I can't write on there. So done that. That now equals 4.05 watts. That's within. That equals 2.2 to 2.5 kilohertz, so that's done. Very good. Let's see how far we can hear down to. So we're listening there to point. If you remember, the best we could hear before was about 0.2, which is there. So now let's go down. 0.2, 0.15, 0.1, 0.06, and I'm off my clock. That's it. And you can still hear that. Let me take the tone off. Tone off. Tone on. still there, right off the clock. What a sensitive set. Oh, he will be pleased. So we'll just see if we've got the squelch anywhere near. I've got 1 minute. So I've set the squelch to full. We're going to apply 100 microvolts. Let's go to the attenuator. So 1, 3, 10, 30. Right, I want it stronger than that. So we'll just pop the squelch up a bit. I want it to open up to 100 microvolts, which it now does. But I want it sensitive at the other end as well. So let's turn the signal generator to standby. That's what the red light shows. Squelch down. Set the threshold. Signal generator on. It's straight in. So it's coming in at 0.25 of a microvolt. And it's leaving at 0.2. So it's a very sensitive squelch. Not that they're the best squelch circuits in the world on these sets. And that just leaves us to do the S9 meter adjustment. And it's well over the top. It's saying plus 30 on 100 microvolts. So we just need to adjust that to S9. And as we turn the signal down, we'll go that down. As we turn it up, we might actually get plus 30-ish eventually. So there we go. We are done. And in the time available. We'll switch it on the air when I come back in 2 hours. Okay, so here we are with it back together. And what I've done as a courtesy, I've popped some black screws in because some of them were silver. And that looks silly. So let's make sure these are set right. And yeah, that looks about right. So we know how sensitive the set is. Let's see. Well, Nana, Roger. Well, that's not going to do anything. Well, as ever, no one is going to talk to us from 35 miles away, which is where they're going to be. They're going to be in Nottingham, perhaps Boston or Lincoln, but there we are. So we'll do an on-the-air test with this, and it's very impressive. So thank you for watching the Rotel RVC240, another fine set from 1981.